Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. I'm Azizah Saswandila, a student of Mathematics Education di Universitas Negeri Padang. In this video, we are going to talk about the derivatives of trigonometric functions. Bismillahirrahmanirrahim. While talking about the derivatives of trigonometric functions, we should master the derivatives of functions and the derivatives of basic trigonometric functions. The derivatives of functions. The derivative of a function f is another function f prime, or dy over dx, or dxf, whose value at any number x dx f of x is equal to limit h approaches 0 of the function f of x plus h minus f of x all over h. There are several rules for finding derivatives. And then the derivatives of trigonometric functions. There are 6 basic trigonometric functions: sin x, cosine x, tangent x, which is equal to sin x over cosine x, cosecant x, which is equal to 1 over sin x, secant x, which is equal to 1 over cosine x, and cotangent x, which is equal to 1 over tangent x, or cosine x over sin x. To help us to derive the trigonometric functions, we use the two helpful limit statements. Limit as h approaches 0 of the function sin h over h is equal to 1. How? Look at this picture. The first picture, there is a right triangle which hypotenuse length is equal to the radius of the quarter circle, 1, and the adjacent OA is equal to cosine theta, because cosine theta is equal to opposite over hypotenuse. The opposite side, AP, which is equal to sine theta. And then the second picture, the area of the sector circle is equal to the measure of the angle over the full angle times PR squared. And the last, a right triangle with adjacent length is equal to radius, and the opposite side length is equal to tangent theta. So we can find the area. The first picture is a right triangle, which area is a half times sine theta times cosine theta. The second, theta over 2p times p times 1 squared. And the third, a half times 1 times tangent theta. If you look at these pictures, we know that the area of picture 1 is less than or equal to the area of the picture 2, and the area of the picture 2 is less than or equal to the area of the picture 3. So a half sine theta cosine theta is less than or equal to theta over 2p times p times 1 squared is less than or equal to a half times tangent theta. If we multiply each part by 2 over sine theta, we get cosine theta is less than or equal to theta over sine theta is less than or equal to 1 over cosine theta. If we write its reciprocal, we get 1 over cosine theta is less than or equal to sine theta over theta is less than or equal to cosine theta. Because of the theta is approximately equal to 0 and cosine theta is approximately equal to 1. So 1 over cosine theta is approximately equal to 1. Cosine theta is approximately equal to 1. So 1 is less than or equal to sine theta over theta is less than equal to 1. We've proven it by limit as h approaches 0 plus sine theta over theta is equal to 1. How about theta approaches 0 negative? Now let a is equal to negative theta. Limit as theta approaches 0 negative of sine theta over theta is equal to limit as theta approaches 0 positive sine negative a over negative a. Why? Because theta is equal to negative a. Now we have substituted it to negative a. So the approximacy also changed to be 0 positive. Limit x approaches 0 sine x over x is equal to 1. So limit theta approaches 0 positive of sine negative a over negative a is equal to 1. Limit right and the limit left is equal. So sine theta over theta is equal to 1. Limit as h approaches 0 of the function 1 minus cos h all over h is equal to 0. Limit h approaches 0 of the function 1 minus cosine h all over h is equal to, we multiply the 1 minus cosine h with its conjugate. So we get limit as h approaches 0 of the function 1 minus cosine h over h times 1 plus cosine h over 1 plus cosine h. This is the identity, right? 1 plus cosine h all over 1 plus cosine h is equal to 1. If we multiply a number by its identity, so it's equal. And by using the trigonometric identity, we know that sine squared of h plus cosine squared of h is equal to 1. The last, we get limit h approaches 0 of the function 1 minus cosine theta all over theta is equal to
0.
Okay, let's continue with the main topic. Theorem A. F of x is equal to sine x. So how about its derivative? F of x is equal to cosine x. How about its derivative? The derivative of sine x by conjecturing. Look at the first picture. When x equals 0, the slope of the tangent is equal to 1. Why? By using the definition, we know that limit h approaches 0 of the function f0 plus h in bracket minus f of 0 all over h, then we will get the slope is equal to 1. And also for the x equals phi over 2, x equals phi, x equals 3 over 2 phi, and x equals phi. And then we plot these points. We'll get 1, 0, negative 1, 0, and 1. It is similar to the cosine x, right? Let's prove it by using derivative definition. dx sine x is equal to limit x approaches 0 of the function sine x plus h minus sine x all over h. And then by using the definition of addition angle of sine x, we get sine x plus h is equal to sine x cosine h plus cosine x sine h. And then we simplify it, we get dx sine x is equal to cosine x. We can also use the dx sine x is equal to limit as h approaches 0 of the function sine of x plus h in bracket minus sine of x minus h in bracket all over 2h. Why can we use it? The derivative of a function is equal to limit as delta x approaches 0 of delta y over delta x. Delta y we use sine x plus h minus sine of x minus h. So the delta x is equal to 2h because x plus h minus in bracket x minus h is equal to h. By simplifying this equation and using sine of x plus h is equal to sine x cosine h plus cosine x sine h, and sine of x minus h is equal to sine x cosine h minus cosine x sine h. This is the formula of addition and subtraction angles of sine. We get dx sine x is equal to cosine x. And then the derivative of cosine x by conjecturing, also using the limit definition. When x equals 0, we get the slope of tangent is 0. We also try for x equals p over 2, p, 3p over 2, and 2 phi. We plot slope of the tangent to the new Cartesian coordinate. We get 0, -1, 0, 1, and 0. Look at this. This is similar to the sine graph, right? But this is the reciprocal. We conjecture the derivative of cosine x is equal to negative sine x. Let's prove it. By using the derivative definition, we know that dx cosine x is equal to limit as h approaches 0 of the function cosine of x plus h in bracket minus cosine x all over h. Don't forget that cosine of x plus h is equal to cosine x cosine h minus sine x sine h. By simplifying this equation, we get dx cosine x is equal to negative sine x. By using this proof, we also get that dx cosine x is equal to negative x. By using addition and subtraction angles in cosine formula. Theorem B. Let's prove that dx tangent x is equal to secant x all squared. Dx cotangent x is equal to negative cosecant squared of x. Dx secant x is equal to secant x tangent x, and dx cosecant x is equal to negative cosecant x tangent x. The derivative of tangent x. Dx tangent x is equal to dx sine x over cosine x. By using the rule of derivatives in quotient formula, derivative of the function u over v is equal to u prime v minus uv prime all over v squared. Let's use it. Dx tangent x is equal to the derivative of sine x is equal to cosine x times cosine x minus sine x times the derivative of cosine x is equal to negative sine x all over cosine x squared. Cosine x times cosine x is equal to cosine x squared. negative sine x times negative sine x is equal to sine x squared. Don't forget that sine x squared plus cosine x squared is equal to 1. This is the trigonometric identity. So the x tangent x is equal to 1 over cosine x squared. 1 over cosine x is secant x. So the x tangent x is equal to secant x squared. Now cotangent x. Dx cotangent x is equal to dx cosine x over sine x. By also using the quotient formula for derivative, we get u prime means cosine x prime. The derivative of cosine x is negative sine x. So negative sine x times sine x minus cosine x times the derivatives of sine x cosine x all over sine x squared. Negative sine x times sine x is equal to negative
Sine x all squared
minus cosine x times cosine x is equal to cosine x squared. We can simplify it to be negative of cosine x squared plus sine x squared all over sine x squared. We get negative 1 over sine x squared. Don't forget that 1 over sine x is equal to cosecant x. So dx cotangent x is equal to negative cosecant x squared. How about the derivative of secant x? Dx secant x is equal to dx
cosine x
upon negative 1. By using the chain formula in derivative, we get that dx
cosine x
upon negative 1 is equal to negative 1 times
cosine x
upon negative 2 times the derivative of
cosine x
is negative sine x. So dx secant x is equal to secant x times tangent x. And then the derivative of cosecant x, dx cosecant x is equal to dx sine x upon negative 1, because cosecant x is equal to 1 over sine x. So 1 over sine x is equal to sine x to the negative 1. By using the chain formula, dx sine x to the negative 1, we get negative sine x to the negative 2 times the derivative of sine x cosine x. So dx cosecant x is equal to negative cosecant x times tangent x. Okay, after that explanation, let's try to answer these questions. Okay, everyone. Number 1. Find the derivative of d to the 21 over dx to the 21 of sine x. We know that the derivative of sine x is equal to cosine x. D to the 21 over dx to the 21 of sine x is equal to the 21st derivative of sine x. Let's try it. The first derivative of sine x is equal to cosine x.
The second derivative of sine x
is equal to the derivative of the first derivative of sine x is equal to the derivative of cosine x, which is negative sine x. The third derivative of sine x is equal to the derivative of negative sine x. So it's equal to negative cosine x. And so on. Look at this. It repeats each 4 times. So this 21st derivative of sine x is equal to the 4n plus 1's derivative of sine x. Because of the remainder is 1 is the first derivative of sine x as the 21st derivative of sine x. So the 21st derivative of sine x is equal to cosine x. How about this question number 2? Find the derivatives of f of x is equal to 5x plus sine 3x. F of x is equal to 4x tangent 7x, and y is equal to sine square root of x. When f of x is equal to 5x plus sine of 3x, by using the addition formula for derivative, f prime of x, the derivative of 5x is equal to 5, and the derivative of sine of 3x is equal to 3 cosine 3x. So f prime of x is equal to 5 plus 3 cosine of 3x. When f of x is equal to 4x tangent of 7x, we use the multiplication rule for derivative. We get f prime of x is equal to 4 tangent 7x plus 28x secant square root of 7x. When y is equal to sine square root of x, by using the chain rule and the power rule. By using the chain rule, sine square root of x, the derivative of sine x is equal to cosine x. So the derivative of sine square root of x is equal to cosine of sine square root of x times the derivative of sine square root of x. Sine square root of x, its derivative is 2 sine x cosine x. Okay, let's continue with the question number 3. Find the equation of the tangent line of the graph of y is equal to cotangent of x at the point phi quarter 1. The derivative of y is equal to cotangent of x is y prime is equal to negative cosecant square root of x. When x is equal to phi quarter, we substitute the phi quarter to the x. So negative cosecant square root of phi over 4. Cosecant of phi over 4 is equal to 1 over sine of phi over 4 is equal to 1 over sine of 45 degree. So it is 2 over root of 2.
2 over root of 2 all squared is
2. So negative cosecant square root of phi over 4 is equal to a negative 2. The required line has slope negative 2 through the point phi quarter 1. And by using the equation line with slope s through the point x1, y1, we got y minus 1 is equal to negative 2 times, in bracket, x minus phi over 4. So we get y is equal to negative 2x plus
phi half
plus 1. Let's try to answer the question number 4. The 2015's derivative of f of x is equal to sine x plus 1 up to 2015 plus 2x minus 1 up to 2014 is, by using chain rule and the power rule and combination with addition rule, f prime of x is equal to the derivative of sine x is equal to cosine x. The derivative x plus 1 up to 2015 is equal to 2015 times x plus 1 up to 2015 minus 1, so up to 2014, plus 2014 times 2x minus 1 up to 2014 times 1 times 2, because we use the chain rule. So the derivative of 2x minus 1 is 2. That's why we multiply it by 2. And also for the second derivative, the derivative of cosine x is equal to negative sine x plus the derivative of 2015 times x plus 1 up to 2014. We get 2014 times 2015 times x plus 1 up to 2013 plus 2014 times 2013 times 2x minus 1 up to 2012 times 2 squared, and so on. But look at this. Look at the third derivative and the fourth derivative and the fifth derivative. We've known that the derivatives of sine x, the derivatives of x plus 1 up to 2015. When it's the first derivative, it's 2015 times x plus 1 up to 2014. When the second derivative, 2015 times 2014 times x plus 1 up to 2013. The coefficient start from 2015 till 2015 minus the degree of derivative. And also for the third derivative, for the fourth derivative, and for the fifth derivative. Look at this. The derivatives of sine x, we've known that it repeats 4 times. But the derivative of x plus 1 up to 2015, look at the coefficient. It starts from 2015 till 2016 minus the degree of derivative. When the third derivative, it starts from 2015 times blah 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 till 2016 minus 3. So look at this. 2015 times blah 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 times 2016 minus 5, which is equal to 2011 for the fifth derivative. For degree of exponent, we've known that the first derivative is equal to 2015, so on. Look at the third nomial. 2x minus 1 all upper 2014. Its derivatives, the coefficient start from 2014 times blah 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 times 2015 times the degree of derivative. Look at the fourth derivative. It starts from 2014 till 2015 minus 4. So 2014 times 2013 times 2012 times 2011 for the fourth derivatives. And the degree of exponent is equal to 2014 times the degree of derivative. Look at the power of 2. 2 upper 1 when the first derivative, 2 upper 2 when add the second derivatives, and so on. So we can conclude that f 2015 of x is equal to negative cosine x. Why? Because it repeats 4 times. The 2015 derivative of sine x is equal to negative cosine x. Plus, because it starts from 2015 times blah 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 times 2016 minus 2015, so it's equal to 1. It's the factorial of 2015 times x plus 1 all upper 2015 minus 2015, so it's equal to 0, plus the coefficient of the third nomial, 2015 times blah 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 times 2015 minus 2015, so it's 0 times blah blah blah. 0 times any number is equal to 0. So we get that The 2015's derivative of x is equal to negative cosine x plus 2015 factorial. That's all from me. Hope you understand it. Thank you so much for watching this video. I'm sorry for my mistakes. Correct me if I'm wrong. That's all. Alhamdulillahirrabbilalamin. Happy fasting. Assalamualaikum warahmatullahi wabarakatuh.